Okay, welcome everybody to the Monday, January 30th, 2017 SIG Service Catalog. So last week we had a good face-to-face in Boulder, and we're going to start off with Mr. Schlesinger saying a few words about that.
Yeah. So for everyone who came, thanks for coming. For everyone who didn't, we'll have a pretty brief summary in here along with some supporting documentation over the next week or so to describe what we did. And just in summary, I was really happy that we all came out writing code that took us much, much closer to an MVP1. So thank you for everyone who participated. I was really happy. I think a lot of us were really happy how it went. So that's it from me.
Yeah, I'll just echo those statements. I think it was really good to get together, and I felt like I could really personally perceive that we're much more on the same page in this meeting than we were in the first one. So that's progress. So I tell you what, Aaron, we had me talking about how to write Kubernetes controller, and then you talk about architecture evolution, but I think we should swap those. Are you comfortable showing what you have now, and then I can talk about Kubernetes controllers?
Yeah, for sure.
Okay.
Let me share my screen here. Okay. Can people all see this? Can you speak up if you cannot see this? Okay, I'll take that as a no, nobody has issues seeing this. So in the morning of the first day of Wednesday at the face-to-face meeting, we discussed at length the current design and the design and architecture of Service Catalog going forward to get us to some feedback. Can everybody still hear me okay? All right. So yeah, we talked about current architecture and architecture going forward to get us to our MVP1 and beyond while still achieving the individual goals of all the participants. So as you might expect, we started with the current architecture as we have now. This is disjoint, as you can see, and obviously it doesn't work from kubectl all the way down to the controller. And the primary reason why it doesn't work is because the API server and the controller can't communicate with each other. So you can imagine how that would cause some problems. So the remainder of the discussion in the morning of Wednesday was how to get from here to our end state. And this is our MVP1 and beyond state. So what we want is an API server that can speak, that kubectl can speak to, and the API server can respond to kubectl commands. And then we want the API server to be able, depending on a command line switch, to talk to TPRs or SCD. So as you can see up in the current state, we currently have SCD integration. It works great. And Morgan, thanks to Morgan, gave us a demo of all of the API server's functionality talking to SCD. So what we need to get to here, the long-term architecture, is to hook the controller up to the API server. And we're planning on doing that via generated client Go bindings to the API server. And then the second to do here, and possibly a slightly bigger to do than the one I just said, is to hook the API server up to TPRs as well, and then turn on that toggleability functionality. So in doing this, we'll get to a pretty similar workflow as eventually we'll get to when we can plug the API server into aggregated APIs once those are baked into Kubernetes. And then when running the API server through an environment variable or similar command line flag, we can just decide on start time whether we want our service catalog and all the related resources to be stored inside of SCD that will be run either in the cluster or will be the same etcd as the Kubernetes core server uses, or and this is something that Deis prefers right now, or the API server will use third-party resources as the controller currently does, as a database, not as a data access mechanism, but just as a database. So that's really the high-level summary. We wrote some code to this end, and as I said just a few seconds ago, Morgan graciously showed us a demo of kubectl talking to the API server, and then the API server persisting inside of etcd. We have a recording of that demo if you scroll up in the Slack history. So the next steps, as I said, are just to hook up the controller and then hook up the API server to the TPR. I'll call it a database right now. And we also have some design documents to this effect as well. And of course, we'll be expanding on this kind of the work to get to this end state over the next weeks. So I just want to open up for some questions right now before we move on to the next topic. So if anyone has questions.
So I think it would be like, I personally get all this stuff. I think it would probably be enlightening for some folks that might be watching on YouTube if we talk a little bit about what the motivation is for API server backed by TPR.
Yeah, that's a good point. So the TPR storage mechanism is something that we at Deis requested. And the reason we requested that is because, at least in the short term, it's kind of difficult for us to go to a customer and either ask one of our customers to hook up an API server that we, the SIG, wrote, either to their etcd cluster that Kubernetes core is using, or to install an etcd operator into their cluster and have the API server speak to that. And then, of course, the implication there is to deal with all backups and disaster recovery concerns that in cluster etcd, the in Kubernetes cluster etcd cluster would come with that. So having TPRs as a backing database effectively uses the Kubernetes built-in kind of arbitrary database. And again, this is for the time being. There may be a solution that comes along with aggregated API support or shortly thereafter that addresses directly this database data storage concern. But for now, we feel that using TPRs as a database for aggregated API servers is a reasonable enough ask for customers that we bring Service Catalog to. So Paul, did that go into the detail you were looking for?
Yeah. And I like I said, I think like probably most of the folks that are running this meeting have been exposed to this idea, but for the benefit of those watching on the internet, I think that was good to go into. So like, as Aaron said, there are like, things are afoot to formalize how do you register APIs. But so far, my perception has been that most of that work is around the API server level constructs, and there's still the unsolved question of thing that you an API that you aggregate still needs somewhere to put its data. And I don't think that anybody's like working on that problem now. It could be argued that it's kind of vendor specific, but I wouldn't be surprised if we get to a point where there's a formal story for it, but it will probably come after the registration mechanics and aggregator are published.
So there is a question in chat from Kent that says, wasn't there an open question of whether it would be possible for the API server to talk to TPRs? This is something about limitations of the REST storage interface. And yes, there was an open question, and there is still some research to be done to answer that question of whether the API server can talk to TPRs. And additionally, the mechanism that the API server would use to talk to TPRs is an implementation of a Go interface called rest.storage. So yeah, there is some research to be done there. I think there was some concern that it will be impossible And of course, if it indeed, the kind of small chance that it is actually impossible, we'll have to go revisit. But based on the small bit of research, about an hour's worth of research that I did on that interface, it doesn't look like it's going to be impossible. It does look like it's going to be an implementation of that storage interface that basically calls through to the Kubernetes core Go client, which in turn, of course, talks to the Kubernetes core API to access TPRs. That's about as far as I personally have gotten. It looks like there might be some other questions in chat, but I can't quite. So there's one from Phil. Phil, can you expand on your question about if we gotten any feedback on this strategy?
Yeah, I think it's just you were talking about doing more research in that area. And since we're basically extending the API machinery, it might be worth just running this plan by them.
Yeah, agree.
So I briefly talked to Daniel Smith about that, and it has been discussed, but nobody has tried to do it yet. And that's what I know.
Did he say go ahead and try it?
Yes.
Okay. Awesome.
Cool. So Doug, there's also a link to your docs branch. Is that unrelated or related to this topic here?
For the most part, it's unrelated, but the reason it came up in my mind is because as I was writing that doc over the weekend, I do talk about the difference between our desired state, which is what you're showing here, versus the current state. I do talk a little bit about that in there. And I'm going to be submitting a PR based on that branch, hopefully before the end of the day. So hopefully you guys will be able to comment on where I got it wrong.
Awesome. Okay. Yeah. Can you ping me and Kent at least when that's up? We can look over.
Yep, we'll do.
Sweet. Okay. So that's the extent I wanted to go into this kind of architectural evolution. So if there are no other questions, I'll turn it back to Paul. Okay, cool. Take it away, Paul.
Okay. So while we were at the face-to-face last week, one of the things that came out of that is it seemed as though people would appreciate some kind of overview of how Kubernetes controllers are written. So I'm going to give a little bit of that now. And I actually spent some time this weekend and earlier today going back over some of the controller infrastructure. And I'm not going to get into that here. I want to just talk about concepts. And then if folks would like to learn more, obviously the code is all on GitHub, so you can go check that out for yourself. And if there's a strong desire for like a tour of a particular controller, I'm happy to do that. So one note before I start is that I'm going to intentionally gloss over discussing specific types because like many other things in Kubernetes, there are multiple mechanisms that are used. Some of them are kind of like the synthesis, like generation N is the synthesis of experience on generation N+1, but there are controllers that use different generations of infrastructure. So let's forget about the specifics for now and just talk in a broad way about what the anatomy of a Kubernetes controller is. So I think you can all see the board behind me. Accurate? All right. Thumbs up from Jessica. So there we go.
From about your chin level up. So.
Yeah. All right. So okay. All right. I got a good amount of board here. So like basically. For those that aren't familiar with the pattern, I think probably most of the people in attendance are, but for those of you watching on YouTube that don't have much experience with the idea of a Kubernetes controller, actually, I don't think I can see what I wrote. Oh, okay. There we go. It's just tiny. Okay, so like before I draw anything else on this board, The basic idea of Kubernetes controllers is, though it may seem mysterious, it's very, very, very simple to grasp. The pattern that controllers in Kubernetes use is called state reconciliation. And there are basically like the mechanism for state reconciliation is like, look at what I'm supposed to be, look at where I am, and then reduce the delta between those two. So the canonical example that we come back to oftentimes is one of a thermostat, where the user of the thermostat says, I want this room to be at 75 degrees. And that's the state that's expected. Then inside a thermostat, there's a little piece of metal that's made of two different types of metal that have different thermal properties. And the effect of this is that like the piece of metal bends as the temperature changes because these two pieces of metal that are joined expand and contract at different rates. So that lets the thermostat read what is the actual temperature. And so you can think of like user has put 75, thermostat reads at 73, and so the thermostat has to activate the furnace and raise the temperature in the room by 2 degrees to get alignment between what's expected and what reality tells us. This is like exactly how Kubernetes controllers work. In the Kubernetes land, the thing that the user set on the thermostat, the 75 degrees, is what we call the spec. And the thing that the the thermostat reads at 73 degrees is called the status. So those of you who are familiar with the details of many of the core Kubernetes resources, like pods, may say, aha, I've seen those things before. And what you will find if you go and look at our resources in Service Catalog is that of the 4 of them, 3 have spec and status. And those model like generalized concerns about, say, for example, the broker resource. Part of the broker resource's spec is what is the URL for this thing? And part of the broker resource's status is what's happening to it. Is it ready? Was there a failure talking to it, et cetera, et cetera. So going back to controllers, the essence of what a controller's job is to do is to look at what is the spec for the thing that is being managed and what's the status of it and take some steps to make them match. So to do this, there's a few concerns that are kind of universal to any controller. You need a way to find out what the spec is. Say this is some hypothetical controller that manages a single resource. Well, the controller needs a way to understand what are the specs for the resources it manages, and then controller has to react to changes in those specs. Like as an example, you've got a new resource, right? Controller needs to say, aha, I've got this new one. I need to do some work, right? And so that's one thing. You need a way to like get information about what you're supposed to do. And then controllers need a way also to change the state of Kubernetes resource that they manage to update the status at the very least. And maybe they need to do some other work. So if we think about how you write a program that does this, here's where I'm going to try to make this more legible. Maybe I'll just go over here. So controller has to have an API client. And when we say an API client, we basically mean an abstraction that lets the controller talk to the API server and get information about the expected state of resources that it manages. So that's all fine and good, but we have two very important mechanisms to keep a controller doing this. And one of those is a list, which is, when I say a list, I mean list is give me all of the resources of this type that you currently have. And then the other mechanism is called watch. And watch is give me updates that happen to these resources as they happen. So we need a thing that does, my super helpful note here about thing that lists and watches. We need a thing that will list and watch for us. And the reason that we need, I'm sorry, let me take that sentence fragment back. So we do a list, and then we do a watch on some resource, right? Well, in order to keep programmers from being lulled into a sense of security and thinking that they are going to have some perfect event stream where events never get dropped, where you always get guaranteed delivery, et cetera, you never have a network partition, watches in the Kubernetes API server terminate automatically after some amount of time. So there is a need for something that will do a list and a watch. Watch terminates naturally, and thing does a relist and then a rewatch. So we have a number of those things. The latest of these is called an informer. So I'm going to erase this stuff. And just write informer here. By the way, if there are any questions as I'm doing this, please don't be afraid to speak up, anybody. It's become very clear to me that after 2+ years of swimming in Kubernetes, things that I take for granted are not obvious to other people. So in the event that I'm doing that, don't hesitate to speak up. So informer is basically it is a thing that knows how to list, knows how to watch, and then there's another thing that it gives us, which is it's a live cache that is populated by list and watch, which is handy if you have a need, say you're watching multiple resources and you need to react to some change in one resource in a way that means you need to get the state of another one. And the final thing that Informer gives us is a way to register handlers for events that happen to resources. So just to make sure this all comes through on YouTube, I'll just make some notes here. Informers list and watch. They have event handlers. And they populate caches.
Now, Paul, you talk about this a lot in terms of managing a single resource, but in the Kubernetes world, do controllers often manage or watch multiple resource types?
Yeah, it's very common to watch multiple resource types. And so let me make a note that informers are per resource. So if you actually go and dig into a controller that is in the Kubernetes core, you'll find that there's that almost every one of them that I can think of off the top of my head, has an informer or some like prior generations analog of what informer is for multiple resources. So for example, there is a controller in Kubernetes that manages attach and detach of persistent disks that come from cloud providers called, amazingly, the attach detach controller. And it has an informer for persistent, for nodes, for persistent volume claims, for persistent volumes, and for pods. This is very common to have multiple resources that have informers in a single controller. Does that answer your question, Doug?
Yeah, just the only follow-up question I have is, would it be one informer that watches multiple resources, or would you have multiple informers, one for each resource?
It's one for each resource.
Got it, thank you.
Okay. So any questions about this before I continue talking? All right, I'm hearing no. So we've got an API client, we've got an informer, and the informer gives us list watching, it gives us caching, it gives us event handlers. So the event handlers are where controllers do their work or on-queue work to be done in another Go routine. So let's just talk about two different flavors of that. Say that we have a really simple arrangement and we can do our work like in some very low amount of time. It's probably fine to just register event handlers with an informer that run our transaction scripts for whatever thing it is that we have to do. Another pattern that controllers use is they will use event handlers to on-queue work that another Go routine is doing, is taking off a queue. So like the two patterns are you do the work inline in an event handler, or you have like some kind of queue and you say unit of work goes onto queue, and you have another Go routine that's like continually taking things off a queue and doing them. Makes sense to everybody? If that makes sense, let me say a few more words about what the long-term picture that Aaron showed earlier looks like in terms of this. So since we are in a situation where we have two API servers, things look a little different in an additive way. So the catalog controller has API clients multiple clients, right? So there's a Kubernetes core client, and then there will be a client for Service Catalog. And in case it's not clear, this is to work with core resources, and this is to work with our Service Catalog resources. So we'll have...
Paul, is that the so-called dynamic client?
Which?
The one you listed as Service Catalog?
I don't think so. I'll be honest with you, Kent. I don't know exactly what dynamic client means, so I don't want to say something that is wrong.
Okay.
So can I follow up on that question Kent just asked?
Yes.
Is this long term, is the Service Catalog client going to be generated
Yes.
Cool.
Yeah, so part of the machinery that we'll use from Kubernetes is a client generator that generates a Golang client, which is a set of interfaces, an implementation of those interfaces that basically makes HTTP requests, and then part of also what the client generator generates is a fake client that is has in addition to the client interface, an imperative programming interface tacked onto it. So you can say, when this verb happens to this noun, you run this function, and it tells the client what to return or how to behave. So we'll have API clients, we'll have informers, and then we will supply event handlers that either implement some transaction scripts or on-queue work that another thing in the controller does. Any questions about this? So as I said, this is not super detailed information, but I have found that just the kind of programming model in general can be a hurdle for folks that haven't been exposed to it to get over. So you can, I'm going to leave it here for now, and I'm happy to do another meeting where I dissect a controller, a real controller, and we can drill into it. But for now, you can just think of it as thermostat mode of thinking about things. So as an example, we've talked a little bit about controllers and watching. I can walk through a quick example. I don't want to spend more than 5 or 10 minutes on it, but I'll do a quick one right now. So one of the resources that we have is the broker resource, which represents a service broker. The broker resource has a spec field, which is a type that contains the URL field. It contains other fields for auth, which are going to change a little bit in terms of exactly what information is stored, but you can think of it basically as broker spec is URL, and how do I do auth to this broker? Broker also has a status field, which is a collection of conditions. Condition is this thing is this attribute of this thing's status has a name, condition failed to get catalog, completely made up example, and conditions are true or false. So when you think about controllers, you can think about the programming model as being you have an API client for Service Catalog that gives you a way to do CRUD and watches on brokers. So the controller will have this catalog API client, and it will make an informer for brokers that handles list watching them, maintains a cache of them, and then also we can register with this informer a handler that runs when a broker is added. So say that I have this hypothetical controller that I've described, and I go and do kubectl create -f broker.yaml, and we make a new broker resource in our API server. Well, the controller is going to get a watch event for that broker that I added, and it's going to run the broker added event handler. And maybe that, forget about on-queuing work, maybe we say we're just going to handle that work in the handler. And so that handler method that we register can implement the transaction script of you go out to the broker, you get its catalog endpoint, and you fetch the service classes that broker offers, take those services, transform them into our service class API resource. You set the status on broker to be ready because you were able to talk to it, you're done. As an applied example. Does that make sense to folks?
So Paul, can you briefly explain why the cache in the informer would be used?
Yeah, so the cache would be used. I'm trying to think of an example of where we use the caching feature. So, like, say that we're talking about persistent volume controller. So for those of you that might not be familiar with how persistent volumes in Kubernetes work, there's basically two pieces to using a persistent volume. There's the actual persistent volume, which represents the storage asset. And then there's another resource called persistent volume claim that says, I want to use something. So there's a controller in Kubernetes that its job is to watch for claims that are not that are made that don't have a volume associated with them, and be the matchmaker that says, aha, I see this claim. I've got this volume that isn't being used, that isn't claimed yet. I'm going to do the transformations on those objects and indicate that they're bound to one another. And then after that, the claim is ready to use. So one of the things that the persistent volume controller does is it maintains a cache of persistent volumes so that when it gets a persistent volume claim that isn't matched, it can go and just look at its cached values without having to relist from the API server.
Cool. Yeah, that makes sense. Thank you.
You're welcome. Any other questions on this? Okay. So that's what I've got for now on this. Please, if anybody would like to go into more detail, like I could be available to do that via Slack, or we could do another recorded meeting or something like that. But that's the gist of it. So I think the last thing on the agenda for today is, Doug, you wanted to talk about daily PR reviews?
Yeah, so at the face-to-face last week, we talked about making sure that we keep our PR velocity up, and we talked about different ways to possibly do that. And we didn't really come to any firm conclusions or anything. But one thing I did want to sort of request of the group is that because we're very much company-based when it comes to PR reviews, meaning we have pretty much 4 main companies there, and we ask that all 3 of the 4 companies approve a PR before it gets merged, in most cases anyway. What I'd like to do is to request that on as best we can anyway, a near daily basis, have at least one person from each company do a quick scan through all the PRs and either comment on it or give an LDTM on it just to keep things moving forward. Because what I'd like to avoid doing is have 2 or more companies not review PRs for 4 or 5 days. And that's just going to cause a hang up and stuff. And I think because we have at least 2 people from each company in the group who are maintainers, I don't think it's a big burden to ask each company to try to look at all PRs at least once a day and give some sort of feedback or comment or something to keep the ball moving forward. And I just want to put that idea out there and see what people thought. Chirp, chirp. Is silence you hate it or silence consent?
So basically, you want to have. So I guess I'm confused. Is this an ask or something else?
It's just an ask. It's not. I'm not looking to make any formal change. Just to say, look, guys, we want to keep our PR count up, but that's not going to happen if people aren't reviewing. So it's just an ask for each company to talk amongst themselves and say, okay, how are we going to try to get at least a look at the PRs on a daily basis? Because I know we're all busy.
Hey, do you guys know about Kubernetes? Does that even work for like those repos?
I'm not sure what is Kubernetes.
I've heard that word before.
All right, I'll paste it in. So it's a dashboard, and it allows you to track like what PRs are open and assigned to you, and helps you identify if like you were the last person to comment on something, so you know if you need to take another look or that sort of thing. It's pretty useful.
Interesting. I'll take a look at that.
So I am happy to commit to that, representing Red Hat.
Diaz or Google guys? Because I know on the IBM side, I'll commit to that between Morgan and I, and hopefully eventually Simon. We'll try to look at all PRs at least once a day on average anyway.
Yeah. So just making sure this is just going through the list of open PRs and reviewing what hasn't what. So for my case, let's say I commit to this. It's me going through the list of open PRs and reviewing what I haven't already reviewed yet, just to make sure I get it.
Yeah, I mean, obviously, if there's a PR out there that you made a comment on or somebody's made a comment on and you can't go any forward with it and you can't go any more forward with it until the PR author makes some changes, then obviously there's nothing to do with that one. But if the PR author believes it's ready for reviews, everybody on the team within a day or so should at least give it a quick look over and say yay or nay.
Got it.
I'm sorry, not everybody team, everybody, one person from each company, sorry.
Got it.
Is it okay for someone to like recuse themselves? Like, let's say you reviewed it and you're like, okay, this looks good, and some other folks have comments. Like, it probably makes sense to just be like, well, I need my approval anymore, or do you want to be in the whole chain?
Can you restate the question slightly? I'm not quite sure I followed.
So one thing I've experienced on PRs I've reviewed is I'll review it and I'll give my feedback, and then if there's other reviewers, I may not feel the need to continually re-review the PR after changes are made by the author.
Well, at that point, you've already given your LGTM, probably, right?
Maybe, yeah. I mean, you probably have given your LGTM, but it's like it does just stick.
As of right now, yeah, we haven't implemented a policy of every time a rebase happens, the LGTMs go away. We don't have that policy yet, so we don't need to worry about it.
You need infrastructure to run a bot.
Okay, well, yeah, I can commit to doing this. For Deus, I think Kent said he'll renew his efforts too, so I don't think it should be a problem from our end.
Okay, cool.
I mean, every business day.
Yeah, and like I said, since it's all company-based reviews, it's just somebody, at least one person from each company, to look at the PRs is all we're looking for, because the list is getting a little long, and as I said before, I get a little antsy when the list of open PRs is above 10, and we're above that now.
The one thing I want to mention is there are work in progress PRs. People label it somehow in whatever way they want to is fine, but I skip those if they're work in progress unless I'm asked, like, can you look at this am I on the right track or whatever. So I'm gonna continue skipping those during my daily walkthrough.
Yeah, I agree with you. I'm in the same boat. I tend to skip those as well unless there's some particular reason I'm interested in it.
Okay.
I can't commit to reviewing daily PRs, but I think that would fall on Vile or Brendan.
That's it, right. Point the finger at them, I agree.
They're not here.
Yeah, and like I said, I'm not looking at this on a per person basis. This is more of a per company basis. So each company figure out how they manage it.
Okay. Well, doesn't seem like we have any objections to that.
Thanks.
All right, so there's about 10 minutes left. Any questions, remaining topics folks would like to discuss that fit into 10 minutes?
I guess I haven't introduced myself. I'm new. I'm from IBM, Simon. I'm pretty new to Kubernetes and just start kicking around with some things like building the binaries and things like that. I'm wondering if there's any architecture charts for the service catalog I can look at, or anything I can like. So I think one of my question is, where is the service catalog within the entire system? I know we have an API server, but and it seems like we right. And I'm not too sure where is our API server compared to the entire system.
So first, I apologize. I should have introduced Simon earlier. He's part of my team. He's coming to us from the Cloud Foundry world, so he has a lot of experience with the service broker type stuff, and he's worked on a lot of CLI type of stuff too. And Simon, you probably missed it because you joined the chat late, but there is a link, and I just pasted it to you in private to some documentation that I'm working on. That's trying to flesh out our architectural picture for our stuff anyway. He won't answer your other question of how does this fit in with necessarily Kubernetes from a bigger perspective. At least I don't think it does yet. But it's at least a start of describing our architecture.
Yeah, so Simon, one, welcome. Two, I can try to answer some of that, some of your questions now. I think that you'll find that there's information about this subject that's in videos, but I would not say yet that it's present in GitHub. I made an empty document that's supposed to hold it, and Doug has, as he said, it has a pull request that dispels some of the stuff. But basically, like, you can think of everything in Service Catalog as, like, in a vacuum, like, there might be many deployment topologies, but probably the way to think about this is it's an extension that will be hosted in Kubernetes in a pod. So we'll probably have a deployment topology that's like, you got a Kubernetes cluster, and you deploy Catalog API server and controller in a pod that runs in Kubernetes, and at sometime in the future after 1.6, we'll have a mechanism that is called API registration, which is basically a proxy that fronts the whole cluster. And this is important because what it will allow us to do is have extensions to Kubernetes that present as part of Kubernetes from an API standpoint. So, like, API aggregator has the Kubernetes core API registered to it, and the other API groups that are part of Kubernetes. It will have our API registered with it, and then, like, a very basic client, instead of talking directly to any particular API server, talks to the aggregator, and the aggregator can just pass along the request to the right place, or for advanced clients, it can say, it can do discovery and say, all right, when you want to talk to this API, you actually talk to this other endpoint.
Okay.
Does that make sense at a really high level?
Yeah, that makes sense. But I have another question from that. So how do we do discovery currently?
This aggregation part that I'm talking about is under development now.
Okay,
Nothing's been released yet.
Okay, but for now, like, since they are running as a pod, so we simply need to know the IP address to the catalog server?
Yeah, you need to know the endpoint right now of the API server.
Okay, thanks.
Okay.
Yeah, that helps a lot. Thank you.
Okay, cool. And Jessica has posted a link to a temporary image for the aggregator if people want to take a look in the chat.
Awesome.
All right. Anything else? All right. Sold. All right. Thanks, everybody, for coming. And we'll catch you all on the flip side. See ya.
See you guys.